Our programs offer many languages. Please visit suprememastertv.com/schedule.
Nos programmes offrent plusieurs langues. Veuillez visiter suprememastertv.com/schedule.
Nuestros programas ofrecen varios idiomas. Visiten suprememastertv.com/schedule.
برامجنا متوفرة بالعديد من اللغات. يرجى زيارة suprememastertv.com/schedule.
Many of us may not be fully aware that batteries are essential to our everyday lives. Nowadays, most electronic devices we use, such as remote controls, cell phones, laptops, and even cars are powered by batteries. Sustainable batteries, eco-friendly solutions for battery-operated devices. Continue watching to find out more.
Vegan, a purified person.
Greetings, radiant viewers. I'm Jerry, the sensible people of the United States Virgin Islands. Thank eco-conscious people like you for helping to protect our environment. Welcome to our show, Sustainable Batteries, Eco-Friendly Solutions for Battery-Operated Devices. Many of us may not be fully aware that batteries are essential to our everyday lives. Nowadays, most electronic devices we use, such as remote controls, cell phones, laptops, and even cars are powered by batteries. As the world moves toward the use of renewable energy from the sun, the wind, and other sources, along with the rapid expansion of the electric vehicles market, the demand for electricity storage is expected to increase dramatically over the next decade. It's estimated that the global battery market size will reach $328.07 billion by 2028, with an annual revenue growth rate of 13.7%. Currently, lithium-ion batteries are widely used for portable electronic devices and electric vehicles because they are rechargeable and have a high energy density. But lithium-ion batteries contain metals such as cobalt, nickel, and lithium that pose sustainability challenges. Mining for these metals creates a large carbon footprint, and acid mine drainage can pollute clean water sources and lead to soil degradation. In addition, many lithium-ion batteries are considered hazardous waste that should not be tossed into the trash because they can create landfill fires that may smolder for many years. As a result of these fires, the toxic chemicals released into the air pose a health risk and contribute to global warming. The chemicals also get trapped in the atmosphere and pollute lakes and streams in the form of rain. To overcome these challenges, researchers, companies, and inventors around the world have been working hard to find materials and technologies to create more eco-friendly batteries with much success. On today's program, we'll explore the world of sustainable battery technology, a key part of the transition to renewable energy. In searching for a material to replace cobalt, researchers have turned to the world's limitless supply of seawater. The technology for conducting electricity in saltwater batteries involves sodium. Saltwater batteries have many advantages. They are safe, easy to recycle, maintenance-free, environmentally friendly, and long-lasting. Among other companies, GreenRock and IBM are showing great potential in developing seawater batteries. GreenRock is an Austrian company that produces and sells saltwater batteries based on sodium-ion technology. The company uses the aqueous sodium-ion technique, which makes use of an aqueous electrolyte consisting of sodium sulfate and water. GreenRock sodium-ion batteries have only one non-circulating electrolyte, as well as an anode, a cathode, an electrolyte, a separator, a current collector, and a battery housing. When charging, the electrical energy flow in the current collector, and the sodium ions migrate to the anode and settle in the anode grid. This process is reversed in the discharging process, where sodium ions migrate to the cathode, and the electrical energy from the battery flows out via the current collector. The battery's construction is similar to that of a lead-acid battery, except that the materials used are all non-toxic, environmentally friendly, and neither flammable nor explosive. The U.S. multinational technology corporation IBM Research has designed a unique cathode and electrolyte combination using a cobalt and nickel-free cathode material and a safe liquid electrolyte with a high flash point. According to the company's blog, this new battery can exceed more than 10,000 watt-hours per liter at optimized power density, outperforming today's standard lithium-ion batteries. Unlike GreenRock batteries, which are used mainly for storage, IBM's discovery holds significant potential for electric vehicle batteries because their technology uses relatively low-cost, non-flammable materials and provides a fast charging option. The company's lab tests showed that the battery can reach an 80% state of charge in less than 5 minutes. IBM is working toward commercializing the battery's development by joining battery manufacturer Citus, electrolyte supplier Central Glass, and German auto manufacturer Mercedes-Benz to create a new next-generation sustainable battery.
Vegan side effects. Prepare to be much loved by humans and all.
Eco-conscious viewers, we'll pause for a moment now to pray for humanity's spiritual upliftment. Please stay tuned to Supreme Master Television. Welcome back to our program, Sustainable Batteries, Eco-Friendly Solutions for Battery-Operated Devices. As discussed earlier, lithium-ion batteries typically use a metal oxide as the cathode and graphite as the anode, in a process that's not sustainable. Researchers at Texas A&M University are currently using machine learning techniques to find more sustainable materials for developing organic metal-free batteries. Dr. Jody Luckenhaus from the Chemical Engineering Department of Texas A&M University in Texas, USA, and her team are utilizing a polypeptide organic radical construction to optimize polymers. The discovery of metal-free redox-active polymers can address society's need for earth-abundant and recyclable or biodegradable materials. Her idea for developing a 100% polymer battery can help move battery production away from cobalt and other precious metals toward sustainable technology. Because of her creation and development of redox-active polymers, Dr. Luckenhaus was chosen to receive the 2022 Edith and Peter O'Donnell Award in Engineering from the Academy of Medicine, Engineering and Science of Texas. Another material discovered by scientists that can replace metal in lithium-ion batteries is soil. It seems hard to believe, but yes, soil-like materials can be used to produce batteries. The Spanish startup Bio has created a biological battery using microorganisms to generate electricity from the soil. The battery consists of an anode and a cathode embedded in the ground and separated by a layer of soil that works like a current. The battery's panel contains electrogenic microorganisms that feed on the organic matter in the soil, producing electrons and protons and sending them to the battery's anode and cathode, respectively. The bio battery is designed with holes that let air enter the battery to provide oxygen, protons and oxygen react with the electrons that arrive via an electrical circuit from the anode to create water and produce energy. This technology has many advantages. Especially unlike solar panels, it takes up no space above ground. Regarding his company's battery, Bio CEO Pablo Vicdarte says, "You have an energy source that's producing electricity during daytime and nighttime, so it's 24/7 production of energy. It doesn't matter if it's raining or snowing, it will produce the same amount of energy." In an effort to reduce the demand for lithium-ion batteries, researchers at Tartu University in Estonia have also found a way to use a soil-like material, peat, to produce batteries. Peat is a dark substance made of decomposed plants that is a plentiful and cheap raw material in Northern Europe. The peat-based technology combines salt and biomass to create sodium-ion batteries. The process includes drying up decomposed peat and heating it to a high temperature after adding natural substances like sodium oxide or zinc chloride to create a special type of carbon. This material can absorb sodium and conduct electricity. Many companies have shown an interest in the team's discoveries, and the technology has been patented in the UK and the US in the hope the idea will work on a commercial scale. Last but not least, researchers from Nanyang Technological University in Singapore have invented paper-thin biodegradable zinc batteries that can decompose in the soil. The batteries include electrode screen printed on both sides of hydrogel-reinforced cellulose paper. The hydrogel fills up the fiber gaps in the cellulose paper and functions as a separator to prevent the electrodes from touching while allowing electrical charge to flow freely between them. Zinc and carbon black are used in the anode ink, while either manganese or nickel is used for the cathode ink. The battery is approximately 0.4 millimeter thick, making it flexible for bending or twisting and potentially useful for foldable smartphones and biomedical sensors used in health monitoring. Thank you, research scientists and companies, for these wonderful sustainable battery developments. We sincerely wish that eco-friendly battery technologies will soon be used widely to help ensure a sustainable future for our planet.
Old or young, all should try to be vegan in order to survive to see the new era. Master Yin Tanam, vegan.
Charitable viewers, thank you for your company today during our program. Sustainable batteries, eco-friendly solutions for battery-operated devices. Coming up next is Supple Cycle, using soap to save lives. May all beings awaken to their true noble self through heaven's divine grace.
Our programs offer many languages. Please visit suprememastertv.com/schedule and suprememastertv.com/GAT.